Assalamu alaikum and good morning. How are you all? Hope you are doing very well. I am your teacher, Miss Amara Imran Malik, and today I want to imagine something unusual. Imagine that we have the power to shrink ourselves smaller than a grain of clay, smaller than a speck of dust, even smaller than the tiny cells in your body. When you keep shrinking until we reach the very small building blocks of living things, very small building blocks of everything around us. Can you imagine? Yes, we are talking about the very smallest, the tiniest part of our bodies. Now you can also imagine another example in your minds. You just have a image of your toy bricks or the blocks. So each single block is like an atom. It's very tiny unit that cannot be broken down further into smaller pieces. But when we snap these building blocks, these bricks, these toy bricks together, we are able to create something new. We are able to make a new structure over there. Similarly, in chemistry, when atoms join together and stay connected, they form a very big molecules. When they stick with each other, when they stay with each other, atoms are joining. These atoms, after joining, make some sort of molecules. They make some sort of structures. These structures are called molecules. So this idea is incredibly very powerful because everything you people see, like air, water, metal, even your body, all these things are made up of different atoms arranged in different ways. So, here the most interesting part, some of these arrangements create invisible gases as well, like the gases in which we people are able to breathe, while others create extremely hard substances like diamond. So, by joining these elements, by joining these atoms, different things are making over there, different things are composing over there. These things can be very lighter, like gases. These things can be very stronger, like diamond. So, today we are going to explore how these tiny building blocks combine together and how their arrangement completely changes the properties of the metal after joining. Got it? Okay. So, here we just have set some sort of learning objectives for us. So let's look at what we are going to achieve in today's lesson. We have four main goals today. First, we will understand that all matter is made up of atoms and molecules and how these particles form the foundation of everything around us. Secondly, we will learn to identify common molecules such as water, which formula is H2O, carbon dioxide like CO2, and understand what those formulas actually mean. Thirdly, we will explore an interesting question like why do some elements exist as single atoms while others prefer to form groups or teams? And finally, this is the most important idea. We will understand how the way atoms are connected with each other, the properties of a substance, how they are able to determine these properties of the substance. For example, why does one substance melt at an extremely low temperature like minus 272 degrees Celsius while other does not melt until the temperature reaches 3550 degrees Celsius? So by the end of the lesson, you should be able to connect structure with behavior, why these elements are behaving like that, which is one of the most important concept in chemistry. Next is what is a molecule? Okay, so let's begin with a key definition video. What is a molecule? A molecule is a group of two or more atoms that are chemically bonded together. These bonds are not weak, they are strong forces that hold atoms tightly together, that hold atoms together. In many molecules, these are called covalent bonds. These forces, which are bonding these atoms, these forces are called covalent bonds, where atoms have to share electrons with each other to stay connected. So, a molecule is the smallest unit of a substance that still behaves like that substance. For example, water. You can take the example of water. What I am just talking about, a molecule. What do you have to clear in your mind? A molecule is the smallest unit of a substance that behaves like a substance. Like if we are talking about water, what is water? Have a look on your screens as well. There is a water molecule over there. So it contains two hydrogen atoms and one oxygen atom. By combining these together, they form a water molecule. But if we separate these atoms, so we will no have longer a water molecule for us. We will no have longer a water for us. You people just will have the hydrogen gas and oxygen gas, which have completely different from hydrogen. Which behave completely different from water, because the properties of these atoms are different from the substance they are able to make, which is water. Are you getting my point? So, molecule is the smallest unit of the substance. Like water molecule is the smallest unit of that water molecule, which water as a substance which people are using. But when we break it into its smaller pieces, into its substituent particles, which are hydrogen gas and oxygen gas, then we will no longer have the water molecule for us. Hope you will get my point. Next, the most important thing over there is like most non-metals in the periodic table prefer to exist as molecules rather than the single atom, while they are more stable when they are bonded together. We already have discussed periodic table. You all must have the copies of them as well. So the elements which were on the right side of your stepped line on the periodic table are non-metals. So we are talking about those elements. Fine. Those elements always prefer to exist as a pair. They prefer to exist in the form of molecules rather than the single atom. Are you getting my point? So they will become more stable. Like we are getting the example of chlorine, which is present on the right side of your step line. So it prefer to stay as Cl2 rather than as a single atom like chlorine. Similarly, there are many other examples, but we will just detract from our main topic. So molecules are not just groups of atoms; they are the stable units that define substance. They are the stable units, like water molecule, which made up of two different elements, that is that is hydrogen and oxygen. But they get stable when these different atoms join together and make a substance for us, which is water, and which has completely different properties from its substituent particles. Okay, so now we are just moving towards your simple molecules, your non-metal elements, how they are behaving. Like in previous slide, we already have discussed this thing, that maximum or most of the non-metals always behave like pair of two atoms, you can say. So some atoms really don't like being alone. So certainly you can say that these elements naturally exist as diatomic molecules. Diatomic molecules means di means two bete. What does it mean? Diatomic molecules which is made up of two atoms. It means they always form pairs of two atoms. So to remember them, we use a simple phrase, or leave it that we will just memorize it by doing different exercises or practice of these things, these elements over there. Each word, represents glass, we have different elements over there which exist in the form of diatomic molecules. So, uh, one of them is hydrogen. Hydrogen, its chemical formula is H2. Hydrogen is a very light element and it is unstable alone. It cannot exist singly, like a single atom as hydrogen. H. Always it is present in the form of two atoms, diatomic molecules, so it share electrons with other atoms or with each other. Like H2 means two different atoms of hydrogen are sharing its one electron with each other by covalent bond. The next is nitrogen beta. So nitrogen makes up 78% of the Earth's atmosphere, and always they form a very strong triple bond, making it very stable. Two nitrogen atoms form a strong triple bond in N3. How they are able to make like single covalent bond, double, triple, we will discuss it later. Because or in general, I am just giving you the clue of that thing. They are having different electrons in their electron shell. Electron valence electron shell, outermost shell of their atoms, they are having different electrons, and to get stability they just have to join with each other to complete their outermost shell. To get stable, they are having to make the bond. So hydrogen has a deficient of one electron in its outermost shell, so it makes single covalent bond. Nitrogen is deficient of three electrons in their outermost shell, so they make triple covalent bond with other atoms. Similarly, oxygen forms a double covalent bond, and it is very essential for us for respiration as well. And why it makes a double covalent bond? Because it is deficient of two valence shell electrons in their outermost shell. That's why they make two covalent bonds. By sharing any other atom two electrons with this, it is able to make a stable molecule. These elements form pairs because they achieve a more stable electron arrangement when they are bonded with each other. So instead of existing as single atom, they travel in teams of two. Always they travel in the team of two, so making them more stable even at your room temperature. And the other example is given over there, also is your fluorine. So fluorine also exists in the form of two. It also makes a single covalent bond because it is deficient of only one atom. Fine. So there is also, I have shared the diagram with you that how oxygen atom is making two covalent bonds over there. So they are sharing, there are two different atoms of oxygen over there, and these two oxygen atoms are sharing two of their electrons with each other, so they are able to get the stable octet shell. Like you can say that their outermost shell now gets stable by having 8 electrons in them. To get this stability, to get or to maintain the 8 electrons in their outermost shell, these two oxygen atoms are joining with each other by covalent bonding. So now we are just moving towards your next, that is sulfur. Okay. So now let's look at slightly larger structure. It is basically, that is sulfur, and sulfur is a yellow, brittle, non-metal element. Yellow, it is yellow in color. Brittle, it is very easy to break, and it's a non-metal because it's present on the right side of your step line on the periodic table. So unlike oxygen, which forms like O2, sulfur forms as 8 molecules. It is a group of 8 atoms. Like when we were talking about oxygen, so it is a group of 2 oxygen atoms. 2 oxygen atoms are joining with each other, are sharing their electrons with each other. But sulfur have to make a giant molecule, and 8 sulfur atoms are over there in a single sulfur molecule, but they do not form a straight chain. Instead, They form a ringed structure and often described as a crown shape. Like you can also see on your screens as well, it looks like a crown shape. So all these sulfur atoms are joining with each other to make up a sulfur molecule, and there are total 8 number of sulfur atoms over there. Why is this important? There must be a question in your mind. Why this is very important? Because structure affects properties. O2 is a small molecule. O2 is a very small molecule, so it is in a gaseous state. It can exist in a gaseous form. It is a gas. It is a small molecule. While sulfur, it is a larger molecule and it is present in a solid state. So the larger size means stronger forces between molecules, which makes sulfur stay solid at room temperature. There must be a stronger forces over there. Fine. So by combining 8 atoms of sulfur together, they have a bigger and the stronger force of attraction between these atoms, which held together, and the atom and the element can exist in the solid state in your room temperature. So this is your you can say your first example, that size and structure, how the size and structure of any element influence the physical property, like whether it is present in the gaseous state or a solid state. So this is the physical property of that element. Oxygen is a very small molecule, so it can exist in the form of it can exist as a gas, while sulfur has a very stronger force of attraction over there. Its size is bigger as compared to oxygen. That is why it can exist in the form of a solid at your room temperature. So if we talk about its molecular formula, you can also have a look on your screens as well, bete. Sulfur atoms join together strongly in a group of 8 to make sulfur molecules. And I have already discussed the ring structure, what is over there, written over there. These 8 atoms are joined in a single ring structure, forming a shaped molecule. This arrangement is very stable and explain why sulfur exists as a solid at room temperature. I think that this explanation is clear to you. Why S8? The S8 ring structure is the most stable form of sulfur at room temperature, and the 8 atoms share electrons to complete their outer shells, making the molecule very stable and giving sulfur its characteristics of the solid state. Next is your different, we will take the example of other giant molecules and structures. So it is let's we just have to step back and look at the bigger picture as well. Not all the substances are structured the same way. We can divide them in different categories, like single atoms, small molecules, you can say single atoms, like they exist singly, loner. They are not making any kind of bond with other atoms. Fine. So not all substances are structured in the same way. We are now just dividing those substances into different categories. So first is noble gases. Noble gases always exist as a single atom, like helium and neon exist as an individual atom because they are stable and do not need to bond with other atom because their outermost shell is complete. You can have a look on your periodic table as well. What is the atomic number of neon? It's 10. So having the 10 atomic number means it is having 2 electrons in its first K shell and 8 electrons in the second shell, and maximum only 8 number of electrons can exist in this shell. It is already it is complete, so it has no need to bond with other atoms. That is how noble gases always exist as individual atoms. Next, we can categorize it as a small molecules. These small molecules, you can say, like oxygen, which exists as O2, nitrogen, which exists as N2, a fluorine, which exists as F2. So all these are the simple and very small groups examples. If we talk about the medium-sized molecules, so medium-sized molecules like um, S8, we already have learned in your previous slide that sulfur as S8 is larger but still separates different units. But if we move towards the giant structures, some elements like carbon, they form huge network of elements. Huge network of atoms, you can say. It has a lot of atoms joined together to make the carbon atom. Fine. You can also see the example of giant structure of picture of that giant structure of covalent structure, the carbon atom. You people can see on your screens as well. So there are millions of atoms. So what is the structural comparison over there? When we were talking about the single atoms, fine, single atoms means like your noble gases, and they are comprises of only one atom. When we talk about small molecules, like small molecules contain, or it comprises of oxygen and nitrogen, nitrogen and fluorine, which comprises of maximum of two atoms with each other, as well as sulfur is also a medium sized molecule, you can say. It is made up of different eight elements over there. So by having all these by having all the by having the look on all these things, eventually we came to an end of that thing, that elements also exist as in the form of different giant structures over there. So the structure of matter, can vary greatly. So it can vary from a single atom to the massive networks of different atoms. So moving towards your next, that how these structures can affect the properties. Small molecules and giant molecules. Now you can have a look on this side by side with according to their different properties. So carbon is one of the most fascinating elements, unlike nitrogen or hydrogen, nitrogen, oxygen, carbon. That does not just form small molecules, it can also form a giant covalent structure, like we already have discussed one example previously, that is diamond. So in these materials, millions of atoms of carbon atoms are connected to form a continuous network. So this means that there are no separate molecules. The entire structure is like one giant molecule. Like given on this diagram, have a look on this structure, covalent structure. No, what I'm just talking about, millions of carbon atoms are connected in a continuous network. What does it mean? That all these are connected with each other. There are no separate molecule of carbon. There are no separate molecule. They are giant structure. The entire structure is like a giant molecule, because all of these elements are strongly bonded, and these materials are extremely very strong, very stable. That is why diamond is one of the hardest substances known in the world. So carbon shows us how powerful large scale bonding can be. It is very hardest element because it is not present in the form of molecule. It is a giant molecule, and all these structures, all these atoms of carbon are joined together with each other. So we already have discussed different properties, like smaller molecules. They are having very low melting point. They can be exist is in the gaseous state in your room temperature. While if we are talking about the giant molecules, they are having a higher melting point because they need a lot of energy to break those bonds which are present between their particles, between the atoms which are holding together. And these giant molecules usually exist in the solid states in their room, at their even room temperature. They have a locked fixed positions over there. So small molecules like all the smaller molecules we already have discussed in, like oxygen, fluorine, and hydrogen, which are double bonded, diatomic molecules. They are having a very weak forces between molecules. So weak forces means they are having very low melting points, and giant structures have a very strong bonds throughout present in their structure. They are having very strong bonds and are having a very higher melting points over there. To break those bonds, we need a lot of energy. So, melting a small molecule only requires separating molecules from each other. But melting a giant structure means you have to break millions of strong bonds. That is why oxygen melts at very low temperature. Oxygen melt at very low temperature, you can say. That is why oxygen can melt at very low temperature, while diamond melts at extremely high temperature. And there is like different examples given to you. If we are talking about single atoms, so it's very low, melting point is very low. It can be exist as a room temperature, at your room temperature in gaseous state. And you can take the examples like helium, neon, and argon. Fine. So if we talk about smaller molecules, that was the single atom molecules, helium, neon, and argon, etc. They are having extremely low melting point, and they always exist in the form of gases. When we move towards the smaller molecules like oxygen, you can see, so oxygen exists as O2. So they are having low melting point. They also exist usually in the form of gases. And different examples of those smaller molecules are like F2, O2, fluorine, oxygen, nitrogen, hydrogen, etc. Next, we will move towards the medium sized molecules. These medium sized molecules, we already have discussed the sulfur molecule, which is made up of S8 sulfur, S8 elements. 8 atoms of sulfur were together to make this medium sized molecule. It have higher melting point and usually exist as a solid state. Higher melting point or having higher melting point, moderate melting point is they are having, and they can exist in the solid state. And different examples I have already mentioned in your slides. These are like sulfur and phosphorus molecules. But when we were talking about the giant molecules, they are having a very high melting point. They always exist in the form of solid states. And the difference between these can be over like 3800 degrees Celsius, you can say, which is enormous, very huge, high temperature. And this shows just how powerful structure is. They are like giant structure. They are having diamond, and its melting point is 3550 degrees Celsius. So it's a huge temperature. While if we're talking about a very single atom small molecules, their melting point is just minus 272 degrees Celsius. And if we talk about other elements, so from this single atom, when we move towards the giant structure, there is a huge difference. And this difference is about like 3800, you can say, almost 3800 degrees Celsius over there. With this, we are just moving towards next, here we are going to compare two different elements like nitrogen and carbon with each other. So nitrogen, firstly, we will talk about its molecular structure. So they can exist as diatomic molecule, like in the form of N2. Two atoms of nitrogen are over there with just two atoms bonding together. And these atoms are having a very weak forces between molecules, very weak forces between different atoms of atom of nitrogens with each other. So intermolecular forces are very weak. While if we talk about carbon atoms, so they have a very stronger intermolecular forces. And energy requirement, if the molecules are strong, are weakly forces are very weak, so it's very obvious for us that they require only a minimum amount of energy to melt. So room temperature provide enough energy for a gaseous state over there. So we can eventually find out that molecules move freely from one place to another because they are in the state of they are having the gaseous state over there. So if we relate it with a carbon atom, so you can say that carbon is having a giant structure. It has very strong bonds everywhere. So atoms locked in places over there and locked in their specific places and must be present in the solid state. They are having a molecular structure, like giant covalent structures. Giant molecular structure is over there. Bonding strength is very high. They are having a very strong covalent bonds over there and require a very high amount of energy, very high amount of heat energy. So its temperature, melting point is very high, and they can only exist in the form of solid state in your room temperature. Next is your different questions which are given over there. So these questions like define molecule. Are you able to give me the definition of a molecule? Tomorrow, in the live class, we will discuss what is the specific definition for molecule, and we will discuss all these question answers that I have just mentioned in this slide. And also, we will also discuss the your workbook material as well. So be very well prepared for that. Um, Stay blessed. Allah Hafiz.